Okay, today we're going to talk about the basics of solving equations by using inverse operations. So to undo an operation in an equation, we want to use inverse operations. The reason we want to undo is that we want to find the value of the variable. So we want the variable to be sitting by itself on one side of the equation. In order to undo an addition, we'll use subtraction. If we want to undo subtraction, we'll use addition. Multiplication and division undo each other. Square and square roots undo each other. And if I want to undo a multiplication by a fraction, we want to divide by the fraction, which is the same thing as multiplying by the reciprocal. So that's just going to look a little bit different. All right, in our first equation that we want to solve, we have a minus 6 is equal to negative 10. If I want the equation to read a equals a number, I have to undo that subtraction by adding 6. And I'm going to have to do that to both sides of the equation to keep it equal. So a minus 6 plus 6 is just a. The minus 6 and plus 6 undo each other. On the right side of the equation, negative 10 plus 6 is negative 4. So our solution is a is equal to negative 4. We can check that in the original equation by replacing the a with negative 4 and just checking that we do get a true equation. Negative 4 minus 6 is 10, so that checks. In the second equation that we want to solve, we have y over 5. Remember that over is division. So now we want to undo the division by multiplying by 5 on both sides of the equation. So we have 5 times y over 5 is equal to 10 times 5. And that multiplication by 5 and division by 5 undo each other. And we're left with y is equal to 10 times 5, which is 50. That's our solution to the equation, and we can check that by replacing y with 50 in the original equation. 50 over 5 equals 10. That's a true equation, so that solution checks. Checking is something that helps us know whether we've made a mistake in solving the original equation. If we have, then we need to look back at our work. In C, we have the square root of x is equal to 8. So we are going to square both sides. The square root of x squared is equal to 8 squared. Square and square roots undo each other. So that gives us x is equal to 64. That's the solution to our equation. We can put it back into the original equation and check the result. The square root of 64 is equal to 8 is our check. That is a true equation, so we know our solution is correct. In the last example, we have 3/5 times x is equal to 6, so we want to undo the times 3/5. Normally we undo multiplication via division, but we can also do it by the same thing as division, which is multiplying by the reciprocal. So I'm going to multiply both sides of the original equation by 5/3. And then we can do some canceling. And what's left is x is equal to 5/3 times 6. Now, a quick way to do that multiplication is to recognize that the over 3 means division, and the 5 in the numerator means multiplication. So I'm going to do this quickly by dividing 6 by 3. So 6 divided by 3 is 2, and times 5 is 10. That's a really quick way to do multiplication by a fraction in your head. We can check the result by replacing the x with 10 in the original equation. So 3/5 times 10 is 6. Again, I'm going to kind of use mental math to do 3/5 times 10. 10 divided by 5, which would be 1/5 of 10, is 2. So 3/5 is 3 2s, or 6. So our solution checks. In order to solve a multi-step equation, or what we're going to do is just 2 steps for the time being, there are 2 operations to undo. If we're undoing them, we have to do them in reverse order. So we want to follow the order of operations in reverse. So we'll take care of subtraction and addition first, and then division and multiplication second, and then exponents, and then whatever is on the inside of the parentheses. Okay, so in example 2, part A, we have 3m plus 3 is equal to 15. I want to think about what's being done to m. In order, m would have to be multiplied by 3 first, and then we would add 3 to it. So if we want to undo those operations, we have to undo the adding of 3 first. So I'll subtract 3 from both sides of the equation. That gives us 3m is equal to 12. And then next, I have to undo the multiplication by 3. So I'll divide both sides by 3. And that will leave us with 3m divided by 3 is m, and 12 divided by 3 is 4. So let's check that in the original equation and make sure that that's correct. 3 times 4 plus 3, we want to check to see that that's 15. So 3 times 4 is 12. 12 plus 3 is 15. I'll put a little check mark to indicate that, yes, our answer is correct. All right, in B, we have something that's set up a little bit differently. Think about what's happening to C. If I took a number C and I had to do things to it in order of operations, it would be the stuff inside the parentheses first, so that adding 3 would happen first, followed by multiplication of that result by 3. So if we are undoing, the first thing that I want to undo is the multiplication by 3, which was the last operation done. So we'll divide by 3, and that will leave us with C plus 3 is equal to 5. And then next we'll subtract 3 to undo the add 3. And we get a result of C is equal to 2. That's our solution. Let's check that to make sure that we're on the right track. 3 times parentheses 2 plus 3 is equal to 15. So evaluating the left side of the equation, that's 3 times what's in the parentheses, which the result is 5, is equal to 15. That checks, and so our solution is correct. All right, let's take a look at the next example. We have x minus 2 over 5. Bear in mind that that horizontal fraction bar groups both the numerator and denominator together. So if I were doing to x, I would do subtraction of 2 from x first, and then divide that result by 5. So if I'm undoing, the first thing that has to be undone is the division by 5. So what I'm going to do to both sides of the equation is I'm going to multiply it by 5. So 5 times x minus 2 over 5 equals 5 times what was originally on the other side of the equation, 4. On the left side, our 5's cancel. That is, the multiplication and division undo each other. So that leaves us with x minus 2 is equal to 5 times 4, which is 20. The next step is to undo the subtraction by adding 2 to both sides, and that gives us a solution of x is equal to 22. Now I'm going to check my answer or my solution in the original equation. Replace the x with 22. We get 22 minus 2 over 5 is 4. That gives me 20 over 5 is 4. That checks, and so we know our solution is correct. In the next equation, we have 2y squared is equal to 8. Think about what's happening to y. In order, y would have to be raised to the second power first, and then multiplied by 2 to get the result of 8. So if we want to undo those operations, the first one to be undone would be the multiplication by 2. We can accomplish that by dividing both sides by 2. Those 2's will cancel since multiplication undoes addition. And then that's going to leave us with y squared is equal to 8 over 2, which is 4. And if y squared is equal to 4, then we can undo by doing a square root. So y is equal to the square root of 4, or y is equal to 2. We can check that result by replacing y with 2 in the original equation. So 2 times 2 squared is equal to 8. Let's check that. We would have to do the exponent first, so that would give us 2 squared is 4, and then 2 times 4 is 8. That solution checks. A note about this solution: y equals 2 is not actually the only solution. This is something we'll talk about in greater detail later in the course, but there is also another solution of y equals negative 2. If you think about checking that solution, negative 2 squared is 4 again, and then times 2 gives you 8, so both of those solutions work in the original equation. But again, we'll talk about that in greater detail later in the course. All right, sometimes it's easier to simplify one or both sides of the equation before solving. So things that we can do are combine like terms, use the distributive property, just to make the equation look a little bit simpler before we start solving. Then we can multiply both sides of the equation also by the least common denominator. In order to clear fractions from the equation, or decimals, since decimals essentially are the same thing as fractions. And I urge you to learn this technique now because it will make your life much, much easier. Okay, there's no fractions in this first equation, so we are just going to do a few things to clean up the left side of the equation. Notice that we have a couple of like terms, 11m and negative 6m. So I need to combine their coefficients. That's going to give me 11m minus 6m is how many m's? 5 m's. So 5m minus 8 is equal to 22. Notice we haven't done anything to both sides of the equation yet. All we're doing is combining some things to make the left side look a little bit simpler. Now think about what's happening to m. We have to undo the minus 8 first. So I'm going to add 8 to both sides of the equation. That will give us 5m is equal to 30. And then we have to divide both sides by 5. And that's going to give us a solution of m is equal to 6. So we can check that in the original equation. 11 times 6 minus 8 minus 6 times 6 hopefully is 22. That's going to give me 66 minus 8 minus 36 is 22. Let's see, 66 minus 36 is 30. 30 minus 8 is 22. Looks like our solution checks. Okay, in the next example, B, we can use the distributive property to simplify the equation a little bit. 3 times 2x is 6x. So we're going to distribute to that first term. Don't forget to distribute to the second term. 3 times negative 6 is negative 18. Now we want to undo the things that are happening to x. The things that are happening to x are multiplication by 6 first, and then subtraction of 18. So to undo those, we're going to undo the subtraction first. And that gives us 28 is equal to 6x. And then we'll undo the multiplication by 6. And then that gives us a result of x is equal to 28 over 6. Now remember, it's easier if we leave our answers in fraction form. So I'm going to leave that as an improper fraction and simply reduce the result. So the result is 28 over 6. 2 goes into both of those. So we can reduce that to 14/3. There's our solution. That can be checked as well. I'm going to forego checking that at this moment, just in the interest of time. All right, our next equation, notice, has some fractions in it. The very first thing we always want to do when we see fractions in the equation is clear them. You will be glad you did this. It's much harder to do if you don't. So the very first thing I'm going to do is to multiply by 6. Now when I multiply by an addition, I have to distribute to both terms. I don't know what I was thinking there. We're definitely not going to multiply by 6 because 6 is not the least common denominator of 5 and 4. The number 20 is. Hopefully you caught my mistake. So we're going to multiply by 20. And so again, think of the easy way to multiply fractions. Remember that over 5 means division. So 20 times 2b over 5, we'll do the over 5 part first. 20 over 5 is 4. 4 times 2b is 8b. And then when we distribute to the second term in that equation, 20 over 4 is 5. 5 times 3b is 15b. On the right side of the equation, 3 times 20 is 60. Now all we have to do is combine some like terms on the left. 8b plus 15b is 23b. And then divide both sides by 23. And that's going to give us a solution of b is equal to 60 over 23, which is an improper fraction, doesn't reduce. We're just going to leave it alone. All right, in D, what you will notice is that we have decimals in the equation. Now, think about what is that place value called that's one digit after the decimal point? That's the tenths place. So if it's a tenth, think about fractions. That's a fraction with a denominator of 10. So all of those decimal values have a denominator of 10. So we are going to multiply through by our least common denominator, which is 10. When we multiply by an addition, we'll have to distribute to both terms. 10 times 1.3 is 13. 10 times 0.5x is 5x. Remember, 0.5 is just a half, so a half of 10 is 5. And then on the right side, negative 3.7 times 10 is negative 37. The next thing we want to do is undo that subtraction on the left side of the equation. I'm sorry, undo the addition by subtraction. And then that will leave us with 5x is equal to, be careful over on the right side, we have two negatives to add together. So negative 37 and negative 13 are negative 50. And then last, we're going to divide through by 5. and then that's going to give us x is equal to negative 10 as a solution. Again, all those solutions can be checked, but I'm going to forgo that in the interest of time. Last example here, where we want to write an equation that represents the situation and then solve it to find the value of x. The situation here is we are given information about angles in a triangle. The thing to remember about angles in a triangle is that their measures add up to 180 degrees. Now there are also some markings in this first triangle. You'll notice that the two angles at the bottom of the triangle are marked in exactly the same way. That means that their measures are the same. So that means that the angle on the left side has a measure of 8x plus 4 degrees as well as the one on the right. So if we add together all three angles, we have 8x plus 4 plus 8x plus 4 plus 3x plus 20. If we add together all three angles, we should get 180. Let's combine like terms. We have 8x, 8x, and 3x. 8x and 8x are 16x, plus 3x is 19x. 4 plus 4 is 8, plus 20 is 28. And then we have 180 on the right side of the equation. Now we're ready to undo some things that are being done to x. So subtract 28, and then that's going to give us 19x is equal to, let's see, 180 minus 20 is 160, minus an additional 8 is 152. And then if we divide both sides by 19, that's going to give us a result of, let's see, how many times does 19 go into 152? I believe it goes 8 times. So that's the value for x. Actually, that's not the answer to the question, though. The answer to the question is, what are the measures of the three angles? So our angle that measured 3x plus 20 is 3 times 8, which is 24, plus 20 is 44 degrees, is one of the angles. The other two angles are both 8x plus 4 degrees. 8 times 8 is 64, plus 8 is 68. So we have 44, 68, and that third angle is the same as the second, 68. Just as a check, those three angles should add up to 180 degrees. Last example, part B. Again, three angles that add up to 180 degrees. One of the angles measures 5x, the second angle measures 4x, and then remember that this right angle that's noted here measures 90 degrees. So 5x plus 4x plus 90 is equal to 180. Combining like terms, that gives us 9x plus 90 on the left side of the equation. So now we're going to start undoing those things that are happening to x. We need to undo we need to undo the addition first by subtraction. That will leave us with 9x is equal to 90. Now we can undo the multiplication by division, and that gives us an x value of 10. Remember again, that's not the answer to the question. The answer to the question is, what are the three angle measures? One of the angle measures is 4x. So 4x is going to give us 40-degree angle measure. That's one. A second angle measures is 5x. So that's going to give us a 50-degree angle. And then the last angle was something that we knew already, 90 degrees. Thank you for your attention today.